Hello and welcome to this second video. Uh, in this video, we will be estimating hourly earnings, which is a non-plausible value using base R script here. Okay, so yeah, my name is Matthew and I'll be taking you through the script. The rationale for the script is available here. And you can see that here along with some important references. And if you're interested in formula, you can look up this technical report here. So today we're just focusing on estimating hourly earnings in PIAAC data. Hourly earnings is a type of continuous variable. So we'll be estimating the mean, the standard error, and also the standard deviation for hourly earnings. So what you first need to do is get your data set for your country, and you can obtain that here as a public use file from this link. It's important to know the code book because you may need to do some recoding and so forth before you analyze the data. So you can check out the code book here. For the technical manual, there's the address here. All right, so before you start, you need to create a folder on your desktop, and you should at least have maybe 3 files in it, right? So for me, you can see that I've got the data set. This is of primary importance. Here we're using Austria, the code book, which I refer to understand how the variables are coded, and also the script, which is the script here that we're running. So once you've done that, you need to make a connection between this folder here and this R session or this R script. To do this, you can run code if you know what you're doing. Here, I'm running this code here on line 37. On a PC, I would press Control Enter, but on a Mac, I press Command Enter. And that makes the link. And I can check and get the working directory. Here it is here. No problem. You can do the manual way by going Session, Set Working Directory, Choose Directory, and then selecting the folder where you have those 3 files. Next, best practice is to clean the global environment of all the data, values, and functions to start a new script. Okay, so we run the code there to do that. Next, I'm going to install a package management package. This package is called Pacman, and it's really useful to use for managing packages for different projects. So if you run this script here, your RStudio will install Pacman if it needs to install it, and also load it to the library, which means it puts a check mark on it here. We can have a quick look. Yeah, puts a check mark on it here so that it's functional within your session. So we can run that. Now our package management is set up quite well. We can use these package management functions to automatically install and load these 3 packages necessary for this script. And this might take some time to install and load those 3 packages. The first package, psych, is for descriptives. The second is for reading in different data sets from different software programs. And the final one is for some type of weighted functions. We can check our directory to see what files we have. Very good, we can see them. At this point, we're going to read in the Austrian data set for cycle 2 PIAAC. The This shouldn't take long. You should see the data frame appear up here after it finishes reading in. There it is. Okay, we have 4,565 objects and nearly 2,500 variables for the PIAAC project. I like to use this dim function as part of the base package to just check the number of rows and number of columns for each data frame. Here we have the replication method, and you can check that. I think that's important for the constant that we're applying later. Okay, and now that we've got the full data set here, we can just like explore it a little bit. When exploring data, I like to use this option, which means that we can see a full output in this console down here. We can run this code, and this ensures that we get a full output down here. Okay, we can do a summary of the first plausible value. Okay, it's 265.47, but we are not so interested in plausible values for this session. We're interested in earning power or hourly earnings, including bonuses. This is a non-plausible value variable. So we can check the very many variables for earning power. We can check missing data and so forth by using this function here. We can have a summary of this earning power variable. We can use table for the deciles. We also can check out this variable here, its structure. We can see that it's a factor and so forth. Attributes. Remember, this data is currently a factor with 10 levels, but we want to change it to a numeric, right? So we switch it to a numeric or coerce it to a numeric, and we can check out the mean and standard deviation and so forth. Okay. So yeah, we're treating this as a continuous variable, even though it's 10 decile groups. That's okay. Let's move to another important variable that we need to conduct the analysis, which is the final full sample weight. Check that that's working. We see there's no NAs. We can check the structure. Okay, it's a number. That's good. And we can describe that as well with a mean and standard deviation. Okay. So now let's also move to the replicate weights. We can see how many replicate weights we have in our data set. Okay, we have 80 for this country. We can also check the first one, describe it, check its structure, ensure that there are 80 of them, check the columns for which these replicate weights exist. Okay, so 2,416th to 2,495th. We can do a descriptive of that, and we can see these replicate weights here. They're all numeric. Okay. So we're not estimating plausible values this time. We did that in another video. So we're skipping straight to estimating hourly earnings. So we can set the name of the variable that we're interested in. Okay, we have it up here. Now we can find out the column position in that data frame for that variable. We can see that it is column position 2,326. Okay, we can also extract the number of replicate weights. These positions, okay, we can see all of them here. Okay, there are 81. This is including the final full sample weight. And we can see the number of replicate weights here. All right, so now what we're doing is we're simply uh, refining this data frame into some more manageable number of columns. And we're simply applying the code to the data, and we only have 82 columns now for all 4,565 cases. Okay. Now, in terms of missing data analysis, in this case, our approach is just to use complete cases. You might use another approach. That's up to you. You might use imputation. Anyway, we're just going to use complete cases in this case. When I run a function like this to reduce the data set to just complete cases, I like to put dim before and after just to see what happens, to see whether there's a reduction or not. In this case, there is a reduction from 4,565 cases to 2,785. So we don't have a full data set, but that's okay. We just have to make do. So here are the key variables in this refined data frame, which is 2,785 cases and only 82 variables. So we're going to push this refined data frame, or we're going to apply some functions to this refined data frame in order to get the mean, standard error, and standard deviations for this earning power. Here's just a quick review of those variables in the data frame. We have earning power, the final sample weight, and the replicate weights. Note that this changes for those countries there, those three countries. Okay, so here, my colleague and I have written functions in order to carry out this analysis. First of all, you need to set the constant, and it's the same for all countries here, except France. You can run that code if it's France, right? Now, we want to run these functions in full, and the functions should be saved over here in the global environment. Let's run the first one. Wonderful. We've got the first function, which is my function, not a PV, mean. So this will generate the mean of a continuous or quasi-continuous variable for PIAAC. This one here is the standard deviation function. So we run this, and it saves the function here. My function, not a PV, standard deviation. Now, we need to apply the function to the data frame, which is this one here, right? This is the refined data frame with just 82 variables and 2,785 observations. So to do that, we need to know where the columns are. We need to know which columns are which. So the non-PV position, we can identify that. The position of the non-PV is the first column, right? It's the first column is the non-PV. The next is the position for the final full sample weight. And it is the second position in that data frame. After that, we have the final replicate weights in the data frame, which are from the third column to the 82nd. Now that we know the positions, we can include these as arguments in the function. So now we can apply the function to that refined data frame in order to generate the mean and standard error and the standard deviation, and also a standard error for the standard deviation. So let's print the mean and standard error for this quasi-continuous variable, earning power. We have 5.4968 and a standard error of 0.05. And for the standard deviation, we have 2.87107 and also a standard error of 0.25 as well. We can just round that to 2 decimal places, and we get our final results that we might report in our descriptive statistics for our paper. All right, so if you have any questions, you can put them in the chat, and yeah, all the best. I hope this is helpful. Thank you for your attention. Bye-bye.